Hello everyone, I am Siddharthan. In this video, we are going to discuss about one of the important data pre-processing technique, which is data standardization. Data standardization is the process of standardizing the data to a common format or common range. Okay, so what does this mean is, so let's say that we have a data set and this data set contains 10 columns of data, and there is a possibility that each column contains data in different range. Say for example, one column can contain data in the range of hundreds and 200s, and one column can contain the data in the range of thousands and 2000s, and one column can contain the data in tens or 20s. Okay, so we need to standardize this data to a common format and to a common range before feeding it to our machine learning algorithm, because it's easier to do analysis and processing on this standard data instead of having an unstandard data. Okay, so this is what we are going to discuss in today's videos. Okay, so in this video we will be taking a sample data set, and in that we will do this data standardization. Okay, so before getting started with this video, if you are new to this channel, I would like to give you a quick introduction to my YouTube channel. And in my YouTube channel, I'm making a hands-on machine learning course with Python. So if you go to my channel, you will see this machine learning course curriculum video. So in this video, I have explained about all the videos and the modules which I will be covering in this machine learning course. So in the description of this video, you can download the course curriculum file. Okay, so you can go to this playlist. So you can see the previous modules we have completed. So we have so far completed 3 modules. The first module was on the machine learning basics, so all the concepts that you need to know about machine learning. And in the second module, I have explained about all the Python basics that are required for machine learning. And in the third module, I have I have given the tutorial on several machine learning libraries in Python, such as NumPy, Pandas, Matplotlib, and Seaborn. And this is the module which we are currently discussing. It's data collection and processing. Okay, so this is the fourth video, and we also have machine learning project videos. So far we have completed about 9 project videos. Okay, so do check out this video, subscribe, and stay tuned for more videos. So you can go to this about section, and here you can get the link for my hands-on data science course with Python. So you can also find my LinkedIn ID, Telegram group, and Facebook group. So you can join those groups for to get notified when I post new videos. Okay, so with that being said, let's get started with today's video. So this video, we are doing this programming in Google Collaboratory. So this environment is Google Collaboratory, and here is where we are going to run our Python programs. Okay, so here there will be a connect option. Okay, so you need to connect your system here. So if you are new to Google Collaboratory, check out my Google Collaboratory basics video. So in that video, I have explained about how to access Google Collaboratory and other things. Okay, so with that being said, let's get started with today's video. So first of all, we need to take a sample data set. Okay, so first we need to import some libraries. So I'll import numpy as np. Okay, so it's the general convention of importing numpy. So numpy is useful for creating numpy arrays, and we need another important libraries, which is pandas. So it is useful to create data frames. So data frames are nothing but structured table which helps us to do analysis more easily. Okay, so I'll also import scalar dot pre-processing. So from this module we are going to import, so we need to give from. So from sklearn.preprocessing import standard scalar. Okay, so this standard scalar is the function which we are going to use to standardize our entire data set. Okay, so we also need to import from sklearn dot model selection import train test split. So this helps us to split our data into training data and testing data. Okay, so we also need one more thing. So I'll import sklearn dot dataset. So from this we will take a sample dataset. So I'll run this. So you need to press shift plus enter to run this cell and go to the next one. Okay, so now we need to load the dataset. So I'll just make a comment here, loading the dataset. Okay, so I'll create a variable as dataset. So dataset is equal to, I'll just call this particular module, which is sklearn dot datasets, and in that we are going to load the breast cancer data. So this data set is used to predict whether a person has breast cancer or not, by analyzing several medical parameters. So if I run this, this will store one instance of this breast cancer data to this variable data set. Okay, so let's run this and let's print and see this data. Okay, so print data set. So you will see the data here. Okay, so you can see there is this sub name called as data. Okay, so this data contains all the values. Okay, so these are the parameters which we will analyze to predict whether a person has breast cancer or not. So there is this target variable, right? So 0 represents that the person has breast cancer in benign stage, and 1 represents the person has cancer in malignant stage. So benign is nothing but the starting stages, and malignant is the most advanced stages where the treatment becomes critical and they are in advanced phase. Okay, so this is what we are going to predict whether the person has the cancer in benign stage or um, in malignant stage. Okay, so this is the data set we have, and we have these feature names. Okay, so you can see this here. Okay, 1 second. So okay, so these are the feature names. So we have this mean smoothness, mean compactness, mean concavity. See, these are the parameters of the cell. Okay, so those cancer cells are analyzed, and these values are got from those cancer cells using some medical scans. Okay, so these are nothing but the feature names. So it will be mentioned here. Okay, so you can see here the this data set contains a list called as array called as feature names, and it contains all the column names. Okay, so we need to import all these. Okay, let's see how we can import this data to a pandas data frame. Okay, so I'll create a data frame as, so first let me put a comment here, loading the data to a pandas data frame. So as you can see here, it's just the numbers are here, and it is hard to do some analysis on that. So if we import that in a structured table, which is a data frame, it is easier to do the analysis. So I'll create the data frame as df. So let's declare it as df, and the df is equal to pd dot data frame. So this will create a data frame, and inside that we need to mention the data which we want to put. So as you can see here, this data set we have named it as data set, and this data contains all the numerical values or the data. So we need to mention that inside this particular function. So data set dot data, and as I told you earlier, the column names are present in the array called as feature names, right? So mention again data set dot feature names. Okay, so this dataset dot data extracts all the numerical data, and this feature names extract all column names. Okay, so let's run this, and let's see the first 5 rows of the data frame. So just put df, the data frame name, dot yet. So this yet function will print the first 5 rows of the data frame. Okay, so as you can see here, this will print the first 5 rows of the data frame. And here there is one important point to note here. We doesn't include this target variable. Okay, so this target which represents the cancer is benign or malignant, so we don't include this. So we will include it in a later point of time. So for now we have just included this particular data. Okay, so you can see here these are the column names, or these are the feature names which you have imported through this. Okay, so now you can see here we have several columns here, and each column has value in different range. So you can see here the first column has values between 10 to 20, and second column also has 10 to 20, whereas the third column has values more than 100, and the mean area is more than 1000. Okay, so and some values are in the range in the less than 0. Okay, so this is where we need to apply data standardization to enable better processing and analysis. Okay, so we need to standardize the data before feeding it to our machine learning algorithm. So that is the idea behind the data standardization. So let's also check how many rows and columns are there. For that you need to mention the data frame. Here the data frame name is df. So df dot shape. So this will tell us the number of rows and columns. So totally we have 569 rows, and we totally have 30 columns. Okay, so we cannot manually standardize all the data, and hence we are using this standard scalar function which we have imported from scalar.preprocessing. Okay, so now what I'm going to do is I'm going to put all this data in a single variable, and I'm going to take this all this target, whether the cancer is malignant or benign, in a different variable. So I'll create x, and I'll store this data frame in this variable x, and I'll create another variable y where I will store all these target values. So these target values can be called by mentioning the data frame dot target. Okay, so let's do that, and x is equal to df, which is the data frame, and y is equal to dataset dot target. Okay, so let's run this. So this X is nothing but the features and Y is the target. So what it means is, so these are the features of the 30 columns, and by analyzing all these features, we need to predict the target, whether the person has cancer, benign or malignant stage. So this is the end result of the data, or end result of this project, which we will get. Okay, so now let's print this X and Y. So print X. So it contains all the features, so it contains all the 30 columns. And now I'll print Y. Okay, so it contains all the targets or all the labels, so the values are either 0 or 1. So we don't need to standardize this data, because we have just two values, either 0 or 1, but we need to standardize this data to have it in a common range. Okay, so okay, now we need to split the data into training data and test data before we are standardizing it. Okay, so I'll make a text here as splitting the data into training data and test data. Okay, so now we need to create four variables as xtrain, xtest, and ytrain and ytest, ytrain and ytest. Okay, so we have imported the train test split function from this sklearn.model selection. So I'm going to use that function, train test split. Okay, so in that we need to mention X and Y. So X is nothing but the features of the data set, and Y is the target. It's either 0 or 1. And I'll also mention the test size. The test size is how much data we want in our test size. So I'll put 0.2. So 0.2 represents it's 20% of the data. So generally we take 10 to 20% of the data as test data. And I'll also mention this random state. So random state is nothing but, it's just to reproduce the code. Say if you give this random state is equal to 3, when you are doing this code, your data will be splitted in the same way that my data is splitting. If you give random state is equal to 2, it will be splitted in a different way. So it is just an identity to, for splitting the data in a specific way. Okay, so we are creating four arrays here. So xtrain is the training data, and ytrain contains the target, either 0 or 1, for all the values in this xtrain, and the xtest is the test data features, and ytest is the corresponding target for xtest. Okay, so we can also standardize the data before splitting the data into training data and test data. But if our data has some outliers, then that will be a problem if we do that. Okay, so outliers are those values which are abnormal. Let's say let's consider this column. So we have this mean compactness, which has the value under 0. So let's say that in one case we have a value around 100 or even 1000. So that value is called as outlier. So in this case, this is a wrong value. So these are nothing but outliers. And if we have any outliers in our data, then if we standardize the data before splitting it, then it will create a problem. So it's better to split the data into training and test data before standardizing it in most cases. Okay, so in this particular data set, it's it doesn't matter, because it is already this data doesn't contain much outliers, so it is a normalized data, and we can split it before standardizing. Okay, so I'll run this will split my data into training data and test data. And now I'll print my xtrain shape. Sorry, I'll first print this x shape. Okay, so x shape and xtrain shape. So xtrain dot shape and xtest dot shape. Okay, cool. So let's run this. So okay, so you can see here our original data contains about 570 data points, so 516 data points, and 80% of it, which is 455, goes to the xtrain, which is the training data, and 114 goes to the test data. Okay, so as we have splitted, now we can do the data standardization. Okay, so I'll create a text here as standardize the data, and I'm going to print the standard deviation of the entire data set. So I'm going to do that by calling this particular data. So this data set contains all the data, and I'm going to find the standard deviation dataset.data. dot std. So if our data has all the values in the same range, in that case the standard deviation should be 1. Okay, so let's run and see whether we are getting it. So as you can see here the standard deviation is 228, which means it means that the data is not in the same range and they varies a lot. Okay, so this is what we need to tackle here. So for this we are going to use this standard scalar function. So we have imported it from sklearn.preprocessing. So I'll create a variable as scalar. So we are going to load the standard scalar in this scalar variable. So standard scalar. Okay, so let's run this. So this standard scalar function will be loaded to this particular variable. So you can search sklearn.preprocessing.standard scalar. So you can see this sklearn documentation here. So you can go through this to understand how the data standardization occurs. Okay, so what happens is this is the final standardized data which we get. So what happens is, so each data point will be taken and the mean will be subtracted from it. So u represents the mean and s represents the variance or standard deviation. Okay, so when you apply this particular formula to all the data points, so we get a standardized data, but it doesn't affect the nature of the data. Okay, so it just change the value range, but it doesn't affect the nature of the data. Okay, so if you do the machine learning task on that, we get the same result. Okay, it doesn't affect how the data really is, but just the range alone. Okay, so now we need to put this standard scalar function which we are loaded to this, and we need to fit this to it. Okay, so use this fit function, and inside that we need to mention xtrain. So we are going to standardize the data of xtrain. So this will fit the data xtrain, and let's run this. So this standard scalar will analyze and understand how the data is distributed in xtrain. Now we need to transform our data based on this standard scalar. Okay, so I'll create an array as xtrain standardized, which is equal to, now we need to use scalar dot transform. Okay, so before we used scalar dot fit, and now we need to transform the data based on this scaling. So scalar dot transform xtrain. Okay, so let's run this. Now you can print xtrain standardized, and see that the values aren't, they are not very different. So we have value in 1.40, 0.61 and minus 0.85. So these values are very close to each other, but you can see previously the values are fixed. Okay, so we have about 1720, and in the next column we have 0.46, and we also add about thousands and 2000, etc. So now you can see that the values are in a similar range. Okay, so this is how you need to standardize the xtrain. But there is another step here. You need to standardize the x test also. Okay, so in this case we don't fit the data again, so we cannot fit the scalar again with x test. No, so we shouldn't do that. We should just transform the data based on this standard scalar. Okay, because this test data contains just 114 examples, and it is not good representation of our entire data set. So we need to standardize our data based on this xtrain fit. Okay, so now let's create a variable as xtest standardized, and xtest standardized is equal to scalar dot transform. So we shouldn't fit it, so we should transform it, and inside it mention xtest. So we want to transform this xtest data. So let's run this. Now this data will be transformed. So as I told you earlier, the standard deviation should be this value. Okay, so if the value is in this range, it means that the values are in not in the same range. So the value should be 1 for or at least closer to 1 to understand that the data are in the same range. So I'll print the standard deviation of xtrain standardized dot std. So std will give us the standard deviation. So let's run this, and standard deviation value is 1.0, which means the data, all the data are in a similar range, but it doesn't affect the nature of our data set. Okay, so that's what we are understanding from here. And you can also print the standard deviation value for x test standardized. Okay, so x test standardized dot standard deviation dot std Okay, so the value is not 1, but it is close to, it's 0.86. So which means that we are transforming based on this extraint, right? So that's why the value is zero point 0.8, but it is very much better than 228. So that's what we are getting. So this is how you need to standardize your data using this standard scalar function. So I hope you have understood the things covered in this video. So that's it about this data standardization. Okay, so thank you so much.